Hey friends, welcome back to the channel. Today we discuss writing a Docker file that is building and running your Spring Boot applications. I'm going to walk you through the exact Docker file that I'm using for multiple applications, so you can use it in your project if you want to. Fun fact, most of you watching this are not yet subscribed to the channel. If you get any value out of this video, please subscribe and like the video. It really helps a lot. Thanks so much, and let's code. Okay, I prepared everything here. So let's firstly check what we've done. I created a super basic application. It's really just an app that has a REST controller so that we can observe from the outside whether it does what it's intended to do. So it has the /ping endpoint and it just returns pong. Now let's check the actual Docker file, and there we are. So as I said, I usually try to use a multi-stage approach. Firstly, building the application and then building the actual image that can be run with a much smaller footprint. So let's go over this line by line. So I'm using Gradle as the build system, and let me back off actually. There's no one way to build this Docker file. It really depends on your setup, on your preferences. You don't have to do this the way I do it here, because you could also build the application locally and then just have a Docker file to copy over that already created jar file using whatever build system that you want to use. It's often also helpful to start with a base image and then pull in all the dependencies, even the JDK or whatever else you're using, whether that's Gradle, etc. I prefer having these images where at least Gradle is already integrated. So you can see I'm using the official Gradle image. So that's Gradle version 8.4. And I'm using JDK 17 because that's mostly the target for my applications. And I'm using the Alpine flavor, which is really small base image to use. And I'm quite familiar with that. Again, your mileage may vary and you can use other base images here. That's just what I'm using. I named this builder because it just is responsible for the first part of the build. I'm creating a work there. So I usually create these subfolders and I'm doing a few things here. So I copy settings and the build file actually. So you can see settings is over here. This is what we're using. It has the meta information about the project and a few information for the plugins if we're using them, as we do. And the build file, right? So this is everything that is required for Gradle to run. And you can see I copy these two files into our work directory. There's another approach. Actually, if you're lazy, you could do copy ... which will just copy everything from the host system into the container. And what I usually like to do with that approach is add a Docker ignore file. So I'm not sure if you're aware of this, but there's .docker ignore, it's a dot file, where you can just specify things to ignore. It's similar to git ignore, but these files will not be copied to the container. So if you run copy ... then these will be ignored. So that's not really relevant for that scenario because I'm copying selectively specific files. I'm copying over the settings and the build file, and then I run Gradle. And let's look at that first. So I run Gradle. I say not to launch the daemon. I've tested multiple approaches here because I invoke Gradle at least twice, but using the daemon was double the time it took without the daemon. Then I'm using console play just to make sure there's no interactive prompts, etc. in a console, which usually there isn't. And then I run Gradle dependencies with only the runtime class path. So this will prompt Gradle to just resolve all the runtime dependencies. So that's compile time and runtime. Importantly, it's not the test dependencies, it's not the development only dependencies, like these kind of things, but it's really just everything needed to run the application. So we resolve all the dependencies and download them already. The reason I'm doing this is because Docker is creating multiple layers based on these commands, right? So at this point then I have a base layer that has all the dependencies that my application needs, and it can be cached for subsequent builds. So if I don't change the dependencies often, this will really speed up the whole build process. Based on that base layer, I'm now copying the source, right? Which is all our code. Now the code is copied over, and now I invoke Gradle once again, no daemon, console plain, and then I just invoke the boot jar task, which will create a jar. And I'm skipping tests usually here because they are executed as part of a different pipeline. You can leave them in whatever floats your boat. For me, it really just helps to just remove them because it will speed up the whole build. I'm running Gradle now, which has all the dependencies in place, and it can just go and compile the source code. Then I'm creating a new directory called layers because afterwards I'm invoking jar and using the layer tools. So Spring by default, unless you change that, will create a jar which is layered. And layered means it has the dependencies, the snapshot dependencies. You can see this here if we take a peek look. Dependencies, snapshot dependencies, the Spring Boot loader, and the actual application. Also, again, in the order in which they change less frequently, right? Dependencies are expected to change less frequently then snapshot dependencies, then Spring Boot loader, then the application. Because if you're working on an application, that is what will change most often. What this tool actually does is it uses the jar that has just been created and it drags out these individual layers and copies them to the file system, right? So we have them over there, which we can use later on. And afterwards, I'm just cleaning up. And that ends the first stage, which is the build, right? At this point, we have a jar file created and we have all these layers extracted. So we can now build the actual image, which is much more lightweight based on that data. So you can see this is the second part. This time I'm using Eclipse Tamarind because I'm using only the JRE. Most applications running in production or anywhere else don't need access to the JDK. If that's different for you, you could recycle that, I guess. You could just use a common base image here and recycle that for both stages. Most of my applications usually need a JRE, so this is why I can just base off this image from the JRE Alpine again. Then it's usually best practice to not run your application as root. You want to avoid that for security reasons, because if your application has security leaks, someone would get access to root privileges. You usually don't want that. But we create a group that's called Spring, and then we add one user in that group, and then we switch to that user. So everything happening now is acting on behalf of the Spring user that we just created. I again create a work directory. I just call it app. You can call it whatever you want. And then I copy from builder, and builder again is the name of that builder over here. I copy over these layers that we extracted as part of that step. And by the way, you can see I could actually use multiple run directives here. So I could say run Gradle, blah, 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 and then run make directory layers. So these could all be separate run directives. I chained them here because each run usually creates a new layer. And that might increase the image size, which is not so much relevant for the builder itself, I guess. But that's still how I approach it. I think it comes down to readability. Again, it's all a trade-off. There's not the correct solution to write the Docker file. You could have multiple run directives here as well. I'm just chaining them here because it counts just as one step. Back to our actual image. So I'm copying over from builder the dependencies, the snapshot dependencies, the Spring Boot loader, and the application. So we have everything laid out in our new image, like everything's there for the application to run. We expose port 8080, and then we have an entry point. So we have the new image, and you need to spin up a process that's permanently on. Otherwise, the container will just shut down. And this is the Java process, and we invoke the jar launcher from Spring Boot. We copied that over previously. And here's an important distinction depending on when you watch this video. So as of Spring Boot 3.2.0 RC1, you have to use that entry point. Before that version, you would just remove launch over here because the jar launcher just got moved into a dedicated directory, right? So I added back. Otherwise, you might bump into a class not found exception for the jar launcher once you want to start the application. And that's pretty much all. There's not too much to it. Let's actually go to the terminal and then see how we run this actually. So I invoke Docker. I'm using build X. Why am I doing this? Because I'm on a Mac with an M1 chip, and I usually have to compile it for or build it for a platform that is not M1 if you want to deploy this to AWS, for example. So I'm using another platform, which is Linux, and then AMD 64, which is correct. I tag the image as Spring Dockerfile, give it the version 1, and then the context is this current directory, and we just get started. And you may know this, it's doing a lot of things. So you can see it says stage 1. Stage 1 is the first part, which is the actual builder, right? So we can see that it's loading the context, it's copying over the build Gradle, and now it's running actually the Gradle dependencies task, which at least for me takes most of the times because it's resolving everything, downloading everything, and creating that layer. And now actually that was wrong what I just said. Stage 1 is our actual file because we didn't give it a proper name. Builder is our first part, the first stage that's already running. And stage 1 again is the second part, which is currently blocked from proceeding further because it now has to wait for these dependencies to be available. So I skipped ahead a little bit so you didn't have to wait all the time. You can see it took 140 seconds for the dependencies call. And then for the second Gradle task, it took another close to 50 seconds. And we can reduce that time at least for this step for the subsequent runs, assuming that none of the dependencies change. And you can see it over here. The builder is executing all the steps. And after it has finished, stage 1, which is our actual image, just kicked in and continue because now it was no longer blocked because it got copy over from the builder. So now let's run the actual container. So we start Docker run. RMIT, so we forward the port 8080 because that's what we're going to use. I call the container Springy because why not? And we need to use Spring Dockerfile 100. And off we go. So we can see the application is starting now, this time from the actual image in the container. That looks all good. Now let's go over to Chrome and actually hit the ping endpoint, and we can see it returns Pong, as should be the case, right? Because if we recall our controller, this is what it is expected to do. And this is how I build my applications using one Dockerfile. Let me know if there are ways to improve it, or if you have questions, just drop them in the comments down below. Thanks for watching, please subscribe, and I'll see you in the next one.